All right, welcome to episode 2 of building an AI agent to play classic adventure games. Some of the feedback I got in my first video was, hey, this is really cool, but let's get into how this actually works. And so to start, I want to set some foundation information here. So this approach is essentially an agent that's built on top of LLMs, which means that it's sitting on top of a model that was built primarily with supervised training, and who knows what else is in there. It's not just neural networks, but it's transformers, and then you don't know what else Grok or OpenAI puts on top of that infrastructure. So you're calling an API and getting back a response. So the way to think about it is they have a tool. It is not a sentient, true intelligence from a sort of a traditional, is it like a human brain? It has features of a human brain and how we work, and it has some superpowers of information retrieval and storage capacity and so on that we don't have. But it's not, from my perspective, intelligent in that sense, but it has intelligence and it is extremely useful. The agent that I'm building on top of that is generic in the sense that it has no idea what game it's playing or what it will encounter, but it is itself a tool that interacts with that LLM and provides it with the right kind of information and context and memory and so on to perform general tasks. And the approach for that, I think, is what we're going to focus on. Okay, this is the main loop of the Engine AI client. So the first step is to take the static instructions and the ego brain state and provide that to the LLM with the current image and essentially ask for the next action that we're going to take. Once we've sent that to the API, we pause the engine and we let the API run. So it can take as long as it needs to take. We've got the engine paused because this usually takes about 20 seconds. When that API call returns, we update the ego brain state with the response. We check if the next action is on the human assist list. This is something like walk from here to here. So right now we don't want to work on object avoidance, so we're having a human walk along the plotted course that the AI provides. If it's not, we unpause the game and take the action, which shows that there's a game loop going on. That gives the game the ability to respond, and then we repeat our loop again. So there's two loops. There's the game loop, which we're pausing and unpausing, and there's our loop, which is only constrained by the time it takes to make the API call. And these are the basic mechanics of the Engine AI client. Now let's look at the instructions for the prompt. We start with an overview that explains the basics of what's going on. For example, you are a player in a classic Sierra-style 3D adventure game, navigating a pixelated, cartoonish 8-bit 16 EGA color world with forced perspective in 320 by 200 resolution. We then say your job is to solve puzzles and come up with your next objective. Your response will always be in the form of a world map, a list of quests, objects, action history, an augmented prompt, and the next action. All coordinates must be in pixel values. Then we give some instructions. So we explain the world map, we explain quests, we explain that quests are priority items that are related to each other and that they have to be marked completed and that they can be hierarchical. We then go on to talk about a list of objects in the scene and in the game, and then after that we provide a list of rules. We have absolute rules, and these are things like if you try to pick something up but it doesn't show up in your inventory, you didn't pick it up. And that's to combat hallucinations. After that, we provide instructions for taking action and then formatting the action command at the end, because we're going to use that. We're going to parse that into something we can give to the game engine. We talk about walkable areas and then instructions on how to move the character. So how to plot a path with coordinates. Quest priorities, and these are complete quests, look at everything once, acquire inventory items, talk to characters, find new rooms, and don't die. We talk about measuring success, solving quests, learning new information, acquiring objects in your inventory, using and combining inventory objects to solve quests, finding new rooms, identifying new quests, scoring points. Then we talk about adding an augmented prompt. This is an interesting idea, so I'm going to read it verbatim. It says, update this section with an itemized list of improved instructions for future executions of this prompt. Only add to this section when you learn something through success. Add game-specific instructions that can lead to increased points. Do not duplicate instructions from the original prompt, and do not contradict instructions from the original prompt. So this is a way for the LLM to provide its own instructions back in future iterations, helping to make this approach dynamic. We also talk about the state of the world after a restart. The game engine needs to understand that all the inventory objects are put back in their place and so on. So you are starting over, but it still has in its memory how it got those items so it can improve on the next run. And then after that, we talk about validating the response. And then we give an output format which shows the world map, the quests, the objects, the action history, the analysis that we want, the augmented prompt instructions, and the next action that we're going to feed to the LLM. So this is the static set of instructions, and the dynamic part has to do with what comes back from the LLM and the basic things that we provide, like inventory from the game engine. We don't provide anything to the AI that a human wouldn't have access to through the game engine. Okay, now we can see that the basic description fits. So we're on top of a static model. We have this loop which has a dynamic process that can pick up new information, understand when we do something well, understand when something doesn't work. It can have many iterations, many cycles, learn from those cycles, even augment its own prompt. There are a couple of other pieces like memory that we need to talk about, and some fine details on context construction and management. We'll get into that in a future video. We're also going to talk about what works well and what doesn't work so well, and things like testing. And then from there, we're going to start making progress together. Thanks for watching.